Good afternoon, everyone. If you are just joining us, welcome to the afternoon session of the virtual implementation workshop on time of flight and quadrupole time of flight mass spectrometry for identification, screening, and confirmation in forensic toxicology and chemistry. We will now hear from Kristen Call with the University of Miami. Kristen, take it away.
Thank you for that introduction. And today I'll be speaking to you about QTOF data review and processing workflows. I am a paid employee of the University of Miami. I have no conflicts of interest, and this webinar is not sponsored by any of the instrument vendors. So a little bit about the University of Miami Toxicology Lab. We have been performing forensic toxicology, specifically human performance toxicology testing for several years, and we currently do testing for Miami-Dade and Broward counties in Florida. We also have a research and clinical components of our laboratory, but I won't be speaking about those today. And then just a little bit about our forensic laboratory structure. We have a director, a toxicologist 3, which is the supervisor, and that's myself. And we also have 2 toxicologist 2s and 3 toxicologist 1s. So for our instrumentation, I just wanted to kind of highlight and give an overview. We do have 2 Agilent LC triple quads, 6460s. We have 2 Agilent LC QTOFs, which I will be talking about more. And then we have a variety of GC instrumentation as well. So for our LC QTOFs, we have an Agilent 1260 HPLC coupled to a 6530 LC QTOF. This is our primary QTOF that we are using at this time. And we have our LC TOF screen method for both blood and urine specimens, as well as 2 targeted assays. We have a targeted urine and blood benzodiazepine confirmatory assay, and then a targeted urine amphetamines and stimulants assay. And for the Agilent 1260 HPLC coupled to a 6545 LC QTOF, that is our new instrument. So we are in the middle of validating methods on that instrument. And our plan is to move all of our qualitative confirmatory targeted assays from the 6530 to the 6545. So I'm going to start with a little bit about our testing workflow, just to give people and all of you an idea about how we're using our TOFs and how they come into our entire scheme for our testing. So the first we will talk about is the driving under the influence case workflow. We also are in South Florida, so we also have boating under the influence. I always just like to make a note of that. But I did want to point out where we have our LC TOF screening assays. So we have for urine and blood, and these are part of our general assays that we use really for all of our samples. Then we have our drug facilitated crime case workflows. This is clearly a lot more in depth. We have far more assays that we're running, but once again, wanted to highlight in here all of our LC TOF and QTOF assays. So we once again have our blood and urine LC TOF assays, as well as in this highlighted in this workflow is our blood and urine benzodiazepines by LC QTOF. And this just really goes to the nature of these types of cases, and that we sometimes might need the additional testing and lower and better sensitivity for benzodiazepines and other CNS depressants. So again, just a brief overview of our analytical methodologies, just as I continue to talk about them, just so everyone has a little bit of idea how the batch workflows, the QC, and the data analysis applies to these methods. So our first one is our LC TOF screen. And I do keep emphasizing LC TOF versus LC QTOF. And this is because having QTOF means that we have the ability to do LC TOF. We have that flight tube. We have the capability for time of flight, and we just aren't using that kind of quadrupole. We're not using MS data. So although we have QTOF instruments, that gives us the ability to use them as LC TOF instruments. So as we continue to go through, I did just want to clarify that, so everyone's like, no one's going, why are you calling it LC TOF when you have QTOF instruments? But the LC TOF screen is for blood and urine specimens. They use the same acquisition and data analysis methods, but they do use different extractions. We have approximately 325 analytes in our library for this. It is non-targeted and it is qualitative only. Here's a little bit about our HPLC and runtime. And we do have both of our QTOFs are dual ESI. and we are running for our TOF screen in MS1 mode, and we have a scan range from 50 to 1000 mass charge. And we are using Agilent Mass Center qualitative software for our data analysis. And for the LC TOF screen, we use retention time and accurate mass data for scoring. And we do have an in-house library that we use for reference. For our benzodiazepines method, once again, it's blood and urine specimens, same acquisition and same data analysis methods. However, once again, different extractions. This method is a targeted method. We have 46 compounds in this method, which includes traditional and MPS benzodiazepines, as well as the Z drugs. Once again, this is qualitative only. Some HPLC information. And here we can see a little bit of a difference from our TOF screen. For this method, we're using it in targeted MS-MS mode, and the MS-MS data is collected at a single fixed collision energy of 20. And for this method, we still collect MS1 data with a scan range of 50 to 1000 master charge. However, that's really used for unknowns or if we need to go back and do some data mining. Once again, using our Agilent Mass Center qualitative data analysis. We do have our in-house library that has the product spectra, which it does not have for our LC TOF screen. And because we have that product spectra, we use retention time, accurate mass, and product spectra for scoring and identification. So our last method that I'll be speaking about is our amphetamines and stimulants. This is for urine specimens only. We have 18 target compounds, including traditional and NPS amphetamines and stimulants. And as all my methods are today, this will be qualitative only. A little bit more about our HPLC, and this is going to be really similar compared to our benzodiazepine method, where we're in targeted MS-MS mode. The difference is we are collecting MS-MS data at 3 fixed collision energies at 10, 20, and 40. And this difference is because we have fewer compounds, so we're able to collect more data and then have usable data. With 46 compounds in our previous method, so many collision energies and MS-MS spectra just decrease the quality of our data. So that's why we choose to only do 1 collision energy for our benzodiazepines method. Once again, we still collect MS1 data, and we are once again using the Agilent Mass Center qualitative data analysis. So let's begin by talking about batch analysis and QC requirements. So I did want to talk about some general considerations for batch and QC. So some of these include for our controls, how many positive and negative controls? What is the frequency for injection or frequency in the batch setup? What concentration should be used? Do you need to have positive controls with all compounds or just a representative number of compounds? And process controls, what are they and are they needed? Then also, though I'm not speaking about any quantitative methods, I did just want to quickly mention a little bit of information about quantitative methods and maybe any requirements for batch and QC. And as I start to talk about the answers to these kind of questions, I did want us to consider that ANSI ASB has a published standard 54, which is the standard for quality control program in forensic toxicology laboratories, that does discuss nearly all of these kind of questions and considerations. And on the next slide, any blue font that you see will be the what I've summarized from that standard. So positive and negative controls, how many of each? So standard 54 states that case samples just must be bracketed by them. So at a minimum, 1 positive and 1 negative control at the beginning and end. The frequency, that is laboratory defined. I will go through what my laboratory uses just for reference. However, really the only thing that needs to be done is that in your procedures and in your policies that you've just defined how many you're going to be using and the frequency in which you're going to have positive and negative controls. For concentrations, for methods with LOD and LOQ, you should have a concentration that it's no greater than 3 times the LOD of the compounds in your methodology. And the burning question, do you need all compounds in your controls or representative number of compounds? Well, for non-targeted, it can be a representative number. And for targeted assays, it should be all of the compounds in your targeted method. Would once again like to say, as I kind of mentioned for frequency, this is laboratory defined. And the information that I'm pulling is from ANSI ASB standard 54, but it's laboratories' decisions on how they implement that. So this is what I'm pulling from the standard, but please do keep in mind where I'm getting these answers from and what I am trying to convey. So process controls, what are they? So process controls are for processes like hydrolysis and oxidation, where you are almost like altering some of the compounds that might be in there. And the answer is for process controls, do we need them? How many? Is you need at least one if you do have a hydrolysis or oxidation, but the concentration of this process control is just established by the laboratory and just needs to be defined. Acceptance criteria for your positive and negative controls. Once again, laboratory defined. So anytime we see this laboratory defined, it just means that it needs to be in the policies and procedures, but it's what the laboratory can meet themselves and what they choose to have as long as it's within reason. So for quantitative methods, for calibrators, the number and concentrations, well, they do need to span the calibration range. And for linear models, there should be a minimum of 4 calibrators, and for quadratic models, there should be a minimum of 6 calibrators. And that's more for statistical significance. And for controls, there should be at a minimum of low and a high control. The low should be no more than 3 times greater than the LOQ, and the high control should be no less than 80% of the upper limit of quantitation. And once again, laboratory defines the acceptance criteria. You just need to have predefined control limits for quantitative assays. Also, some considerations are instrument performance. So this one I added in. We should have pre-batch maintenance and instrument checks, so tunes and calibrations, and you should have criteria set for that. And Standard 54 mentions that you need a procedure for evaluating instrument performance during the run. The good news is that's why we have positive and negative controls. So using your positive and negative controls, as well as maybe solvent blanks, you are evaluating the instrument performance. So as long as you have that criteria, it kind of makes it really easy, because I would say that most labs are already doing this and it's no extra step. You just kind of need to acknowledge that you are doing it. So internal standard recovery. For qualitative, you just need to have minimum recovery requirements that are defined. And for quantitative assays, you should have minimum and maximum recovery requirements that are once again defined in procedures and policies. Carryover should be evaluated. And this can be done by having solvent blanks before samples or negative controls preceding samples, and they just should not contain any analytes of interest. Dilutions, this was something that was put in standard 54 for quantitative. The dilutions and the values must be within the calibration range. And then I added in consider dilutions for qualitative analyses if there are overloaded peaks or overloaded samples. That is what my laboratory does. So just wanted to add that in. So let's talk a little bit about the specific requirements that we have at the University of Miami in our toxicology lab. So for batch analyses in QC, here's kind of our requirements. We need at least 1 positive and negative control at the beginning and end of the sequence. Additionally, we say for the frequency that we also need positive and negative controls every 10 K samples. We do have process controls included if they are applicable to the method and the extraction. And for our internal standard recovery requirements, since these are all qualitative assays, we have our requirements is that we need a minimum of 75% of our internal standards present, and then we don't have to take any additional action. If we do have less than 75% of our internal standards present, then we do have additional action, which may include repeating the sample, data evaluation and corrective action. It really just depends. And then we also have blanks or negative controls that precede every case sample, and that is a requirement for us. So our QC criteria for acceptable results. So these are not case samples. I did want to specify, I will go through that, but for our QC, we have to have our retention time within 0.115 minutes. We have to have a mass difference, or sometimes referred to as mass error. We have to have a ppm of less than or equal to 10, plus or minus 10. We have score or scores that need to be greater than 70. Our negative control should not contain any target analytes, only our internal standards, and the minimum internal standard requirements also need to be met by our negative controls. And for our positive controls, they should contain 75% or more of our target analytes in order to pass. So let's be a little bit more specific for our methods because there are some differences. So for our LC-TOF screen, the way that our QC is set up is we have matrix matched representative extracted positive controls. I know that's a mouthful. And for our blood method, we have our extracted controls at 100 nanogram per mil. And for our urine, we have them at 200 nanogram per mil. This is a non-targeted method. So that means we can just have a representative number and representative controls. The controls that we do extract include the about 60 compounds. And this includes the common drugs of abuse and common drug classes, which are the CNS stimulants. So we have our amphetamines and our cocaine. We have our CNS depressants, which includes benzodiazepines, as well as barbiturates. And then our opioids, which includes our opiates, as well as our synthetic opioids. And then we also have additional unextracted or neat samples. And this is to help us check the retention time. So we have a sample with about 100 or more additional compounds that we do run at the beginning of our sequence, the beginning of our batch. And this is just really for retention time check because we do use retention time as part of our criteria. And these are also additional common drugs. A lot of prescription drugs are over the counter. It's just a way for us to check that we have not had retention time shifting. And for this methodology, we don't have a hydrolysis, we don't have an oxidation, so we don't need process controls. So for our LC-QTOF confirmatory methods, we have a little bit different. So we still use the matrix matched positive controls, positive and negative controls, but these must contain all targeted compounds because this is a targeted method. We have 2 to 3 control concentrations that we use. We have our LOD sample, which is also sometimes our low control, but we might also have a separate LOD sample, a separate low control, which again cannot be more than 3 times the LOD concentration. And then we have a high control, which does vary between the methods in the matrix. However, it's usually something like 10 to 20 times greater than the LOD or the low control. And we do use a process control for one of these confirmatory methods. We do a hydrolysis in our urine benzodiazepines method. So we do have a glucuronide control for that so that we can ensure that the hydrolysis was successful. Okay, so now that we've looked at our methods, let's talk a little bit about data analysis. So some general considerations again. And I did want to point out that ANSI ASB standard 98 is published, and it is the standard for mass spectral analysis and forensic toxicology. So some of the kind of extra information that I have, if it's in the blue text, it is once again referring to now this standard. So for positive identification criteria, there should be a mass difference or the ppm requirement. This is required. But like so many of these, it's laboratory defined. You just need to have stated what it is. But again, as long as it's within reason, it's up to the laboratory. There should be retention time requirements. This is something I've added in because we use retention time, but not all laboratories use retention time when using QTOF or TOF methods. So if it's applicable, you should have retention time requirements. Isotopic distribution, tolerance, this is required, but laboratory defined. And the use of laboratories for reference or for scoring and identification, I have a little asterisk by this because there are 2 options, and this is the option I'm going to talk about, or in the standard, in standard 98, they say that you can use libraries for reference or scoring, or you have to have additional criteria for how you're looking at the MS spectra. But since my laboratory uses the libraries for reference, that's what I'm going to talk about. And with that, we have score requirements that we also need. And then QC requirements. So standard 98 mentions your QC requirements should be as mentioned in standard 54, and they are laboratory defined. One other thing I did want to kind of pull out from positive identification criteria and from standard 98 is they do have a line that says no ion should be present at a relative abundance greater than 50% of the base peak if it's not in the reference spectrum. And this is when you're collecting, so multi-stage MS. So in this case, it would be like targeted MS or MS to the N. So if you are looking for scoring and identification, and there is an additional ion that is greater than 50% of the base peak in your sample spectrum, and it's not there in the reference spectrum, you should not call an identification based on that. And then I did also just want to consider data analysis workflows and maybe some automations. So let's jump into the University of Miami Toxicology Lab general requirements for all of our methods. And this is specifically now for case specimens and case samples. We do have a mass difference requirement, and that is in order to call a target or an analyte positive, it must be within plus or minus 5 ppm. If it's within plus or minus 5 to 10 ppm, it can be reported as presumptive positive. And if it's greater than plus or minus 10 ppm, we do not report it because it does not meet our criteria. Then we have the retention time requirements, which are the same as our controls at plus or minus 0.115 minutes. And the reason that we have it based on minutes and we have this is this was the default, but what we have found is in Agilent, QTOF, qualitative analysis, and we do not have the ability to designate plus or minus percentage of a retention time because you don't have to use retention time for these methodologies. So we had to set in terms of minutes instead of percentages. And for all of our other methods, we do have for GC methods either plus or minus 2% of the retention time or plus or minus 3% of the retention time for LC. But that is why this one is different. We would love to do that. It's just not, we have never found that it's been able to be set. And then we use our in-house libraries, which are referred to as PCDLs by Agilent, and we use those for reference for scoring and identification. And the score for this does include the isotopic distribution as a component. So that kind of takes place of one of the requirements that I mentioned on the previous slide. And then QC requirements, kind of as I already discussed, our negative controls can't contain any reported compound. Case samples must be bracketed by passing positive controls and negative, but passing for that reported, passing positive control for that reported compound. And the preceding blank or negative control should not contain any of the reported compounds. So let's talk a little bit about scoring before we really jump in. And it might be a little bit difficult to see, but this is a little bit of a breakdown of the contribution to the score, and this is from our data analysis. The score takes into account the mass difference, which is the ppm. It takes into account isotope abundance and spacing if they're applicable, and also compares the retention time and the other information to the database or the library, which is the PCDL. And that is the score. That's what it's called in the reports and in the software, but sometimes we call it total score. And this is different from the library score. And the library score is also being compared to the database or the library and that PCDL, but it uses MS spectra that are added into the library, either during optimization or if it's like a purchased or an included reference library, it would be the MS spectra that is in there. So the library score is what takes into account, is used during our targeted MS methods, whereas our LC TOF screen only uses score. So let's talk a little bit about our data analysis workflow. For all of our methods, we have set up automated workflows. So you can create a custom workflow or use an Agilent out-of-the-box workflow. You can also have the option to check when loading data files, which is the screen that I have on the right-hand side. You can check it so that the workflow begins as soon as you open a data file. And the workflow is method dependent. So you can see I have the little circle checked to use the current method. So we always load our method as we open up data analysis and before we load any data files. And then I have the checkbox that says run method workflow. So since I'm using the current method, let's run that method workflow. There is the option to uncheck that, and right above it, it says load results data. So if you've ever closed out of a data file, you've completed it, you've saved it, but you need to reopen it to take a look at it, you would uncheck the run method workflow and check load results data. And that's kind of how you get around that, but you're not messing with your automation. So this is, I just wanted to show for our LC TOF screen methods, this is our workflow. We do have a custom workflow, and you can see on the bottom the actions to be run. So we have delete previous results. That's why we don't want to rerun it if we've already analyzed a data file. And then we have it to do identification by find by formula, which I will discuss just a little bit soon. But then for our LC QTOF confirmatory methods, we once again have a custom workflow, and down at the bottom, you can see we have extract additional chromatograms that we might have designated. We have it to once again try to identify compounds by find by formula, but then we also have it do a compound search using a database and a library, which would be our PCDL, which has the MS data. And we need to do that search compounds so that it does use the MS data and tries to obtain that library score. So I did also just want to point out that this is like the identification workflow, and this is where it references the PCDL that we're going to use and just a little bit of information about that. And we do have a checkbox that says include both scores and overall ID score, so that we'll have our score and our library score. So I've talked about automated workflows, but there are manual workflows as well. So you don't have to set up an automated one. You can select your ID options under method editor. So we can see on the left-hand side, find by formula is kind of highlighted, and here's some information about find by formula. It's the target source, which would be our PCDL. That's what we can see. And sometimes we use these, what I'm calling manual workflows, is if we update, say, our retention time. And in our PCDL, we said, oh, we've seen some drift with this compound over time. Its retention time is not accurate anymore. Let's update our retention time in the PCDL and reanalyze our data. So instead of running the whole method workflow again and deleting all the old results, we can just reanalyze selected data files, and we can hit find by formula, and it will reanalyze and reference the updated version of the PCDL and still provide us those results. It saves a little bit of time. So that's why it's kind of easier to do it that way. So let's talk a little bit about our data analysis views now. So in build 10 of Agilent Mass Center Qualitative Analysis, we have two different views, navigator and compound view. And previous versions of qualitative analysis in 7 and 8, I think they have a 9. These were actually two different applications and icons that you can use in tandem, but they merged them back together. So it's in qualitative analysis, but it's just two different views. So this first view is navigator view. And this is where we're really looking at some general information about our data files. So we can see that top left portion has some acquisition information, data file name. The bottom left portion is where we have where we can sort by data files. You can click on individual data files, look at any chromatograms that are there. And if I had pressed that plus sign, we would be able to see the list of compounds that are identified in those samples. We don't usually use this to look at individual compounds because it's not really efficient in this view, but you can. We do use this view because we're able to load a tool called a mass calculator, where we put in the molecular formula and it gives us the M+H, the accurate mass to 4 decimal places. And this is where we can do extracted ion chromatograms if we're trying to see if there is a specific compound and maybe retention time has shifted. That's how we maybe look for things in our positive controls that might have shifted. This is also the screen where we look for unknown peaks and try to get their accurate mass and retention time. But really, this is more of like an overview page. So our compound view, this is where we're really, for the most part, looking at individual compound results. We look at the results from the PCDL library and how they come up from the workflow. We also have set criteria here so that we aren't seeing poor matches. So we say the scores have to be 70 or above, and then we say the ppm need to be plus or minus 10 for us to report. We do, for our kind of thresholds for these, allow a little bit of leeway. We might say populate anything with a score of 60 and with a ppm of plus or minus 20, so that we can just take a look just in case there's a compound that's overloaded and maybe that threw out the ppm. However, we won't report those. But this is also where we can delete those poor matches from a data file and from reports. So it would be this screen. let's take a little bit of a closer look. So I just highlighted norcocaine. We can see this is once again in compound view. So we can see it is listed in our compound list in that upper left portion. We can see in the bottom left portion that we have some information, including score, the ppm, and then it's a little bit small, but we also do have our compound chromatogram. So on the right-hand side, so we can see our chromatogram, make sure it really does look like a peak. It meets any chromatographic criteria that we have. So then let's just kind of zoom in a little bit more. So this is looking at our compound list, and I have to scroll over to get these. So this is all the same row. I have norcocaine highlighted, and I can see things like mass, abundance, base peak information, data file. And then I can also see and that's in the top photo. And on the bottom photo, I can see the score, and then I can see ID type techniques applied, which is FBF, find by formula. And then we also just have some more information. You can't see the green because I have it highlighted, but if it meets our criteria, it's going to highlight it green. As you can see, the one above it, it says low score because we have a low score. It's at 72. And then the other ones that are green mean that they're great identifications. We do take a look at them, but that's why it's being highlighted different colors. And then our compound view, I will go back, but this one is for our LC TOF screen. So one thing that we are missing is a library search score and the database search information, but we can see in the confirmatory that we do have that. So we also see ID techniques applied. It says DB search, library search, find by formula, because it does all of those things. We also have additional scores. We have a library search score. We still have those color-coded flags, which is nice. And we also have a little bit of we have the retention time difference all the way to the right on the bottom image. We do have the retention time difference there as well. And these are just populated when we use that library search function and when we have MS data. So did want to highlight what's called the compound identification results. Once again, I'm looking back at norcocaine, and we can see kind of toward the top of this image, it says ID techniques applied. It's find by formula. This was from our TOF screen, so that is the only technique that we have applied for our TOF screen. But we can see the name, formula, the M plus H. We can see the target mass. We can see the ppm difference. We see our score, our retention time, and the target, and how those are different. And then our kind of final score all the way to the right. So this provides a lot of information. And these windows that I've highlighted over these last couple of slides were all in that large compounds view screen. They were all there. It's just kind of what you're looking at. So did just want to quickly go through some of specific criteria for reporting results for LC TOF screen methods. So we have only the retention time and accurate mass that's used for scoring. So we only have one score provided. In order to report as positive, it must be 70 or greater. And we don't have an area threshold cutoff. So any positive or presumptive positive result does need to be confirmed, which is why we don't have an area cutoff, because we also have a variety of LODs. So it would be really difficult to run standards for everything because we just run the representative positive controls for this method. So for our confirmatory method, we have the retention time, accurate mass, and MS spectra that are used for scoring. So we have two scores that are calculated, both our score and library score. For these methods, since they're confirmatory methods, in order to report a sample as positive, it needs to be both scores need to be 80 or higher. And then for presumptive positive, it can be both scores need to be 70 or higher. And for both of these, for both our TOF method and the confirmatory methods, we need to also consider our ppm, which is criteria, but that's the same across all methods. We also do have an area threshold for reporting, and that would be our LOD sample because we have validated LODs for these, and we just need to make sure that we are not going below that LOD sample threshold. Quickly, I did just want to mention for our reports, Agilent does have generic Excel and PDF reports. You can also create custom reports where you can include and exclude information, including logos, header information, columns, and compound tables. and spectra and images. And this was just a screen grab of where you go to print the reports and options that are available. Also, for result importing, it really depends on individual laboratories and any LIS systems they have, if you can automatically import results. So this is just a quick view of our reports. We have the compound table, the chromatograms, and the mass spectral data. This would be for our TOF screen, so we don't have a library match here. We just have accurate mass, and we can see everything meets criteria. We also don't have a library score in that far right column in our summary table, which is different than our confirmatory reports. That whole table is filled in. We have both our score and library score. We still have the chromatogram and the MS, but we also have additional information, which includes our observed spectrum and our library spectrum to make sure that they are matching, and our MS spectrum. So just a quick summary. For batch analysis and QC requirements, this information and these policies and procedures are set by individual laboratories. There will very likely and should be different requirements for qualitative non-targeted, qualitative targeted, and quantitative assays. And as a reference, ANSI ASB standard 54 can be used to assist with creating these policies. And for data analysis, this is really dependent on instruments, vendor software, and type of test. And there are different requirements for qualitative non-targeted versus targeted. ANSI ASB standard 98 can be used to assist with these laboratory policies. And because we love our automated workflows, there are some softwares that allow for automated workflows for easier data analysis and review. And with that, those are my references. And if you have any questions, please do let me know. These are nice formal headshots of my animals and my pets, but please feel free to let me know what questions you have. Thank you so much.
Thank you, Kristen, for that informative presentation. Up next, we will hear from Ryan Peters with the Wisconsin Laboratory of Hygiene.
Hello, everyone. I'm Ryan Peters, and I'll be talking about data management and reporting. Before we get started, I have no conflicts of interest. This webinar isn't sponsored by anyone or anything, though it might seem like it is at times. I'm employed by the Wisconsin State Lab of Hygiene, but the views expressed here are my own. And I will be receiving an honorarium for this presentation. So we use Waters instrumentation here at our lab. So my presentation will be very Waters and Unify-centric. That being said, I hope that some of it will translate to other systems, or at least get you thinking about your own workflow processes. I have 5 topics that I'll go over during this presentation. First, we all know that these instruments have limitations, but we have to find a way around them to make the data easier to process and the time from analysis to report faster. By organizing and filtering the match list, we can decide what we see and what we don't. For instance, do matches with no fragments and less than 2,000 response matter to us? We can set blanket cutoffs that make exceptions for any outliers using filters in Unify. Next, have you seen compounds that lose ionization in the middle of a peak because they've saturated the detector? Or maybe there's a compound that's breaking down before it gets to the detector. Let's make extra ways to detect them so we don't miss anything because of high mass error. Not sure if people know of AutoHotkey or not, but it's an immensely powerful tool to string together keystrokes, mouse clicks, and Windows automation. I've been using version 1 for a while and have built some productivity scripts related to Unify and other Windows tasks. My examples in my slide will be in version 1. Version 2 is now out and should be easier for programmers to write code for. Think about things that you do all the time that are repetitive. We can make them hotkeys that are easier, faster, and more consistent. One example, switching from one sample to the next and moving to the top of the match list. It almost feels like this should be an included hotkey in Unify, but since it's not, we can build one. Reporting. When reporting, we need a large amount that contains everything about our run that we can use for discussion without the software present, like for open records requests. But we can also separate reports for resulting matches on samples, or a QC report to summarize how your quality controls are looking for a particular batch. We can then use that reported QC report to track QC material over time in something like Excel. And lastly, data storage. These files are huge. I'll show you how we handle ours. I'm not sure it's the best way, but it works for us. It seems to keep our storage requirement to a manageable level. Before we get to all that, let me tell you a little bit about myself and my lab. I work at the Wisconsin State Lab of Hygiene in Madison, Wisconsin. We test about 10,000 samples per year for drugs. This is a look inside of our walk-in cooler. The racks with Post-its on them are waiting for either alcohol or screen testing. We have two Xevo G2XS QTOFs. The first one went online in 2019, the second in 2020. Their names are Orville and Wilbur. This one is a picture of Orville. All right, let's dig right into Unify. Here's an identified components list in Unify. Look how many matches are found. I doubt you can see it in this small slide, but this QC material has 673 matches. That's way more than we should have to review. So are they all relevant? How can we decide what is or isn't? Unify uses filters to limit these matches. Then you can add the filter to a workflow step to use on all of your analyses. In our filters, we use item tags to differentiate some compounds from others. For instance, we run all compounds through our method to make sure that we're able to see them, then give them each an item tag called in-house RT, so we know to treat them differently from those that we haven't run. It's important that you run each of your suspected compounds on your instrument at your detection limits to find this out. Know how these compounds perform and what their limitations are on your method and instrumentation. For instance, we have issues seeing buprenorphine and norbuprenorphine. The opioids aren't great either. Carboxy and carboxyglucuronide have some weird match issues. But when you're looking for hundreds of compounds in one simple extraction screen, you'll have to deal with the consequences. So we do by making filters so that we don't miss anything important. All right, let's start with item tags. Item tags exist in the compound library entries as well as within the method, but updating in one doesn't cause an update in the other. Many of these are pre-populated from Waters, but you can make your own as you see fit. My favorite item tag that we use is called in-house RT. Talked about it a little bit in the last slide. It designates that we've run a compound at our lab from a stock and know that the retention time is correct and that the fragments are solid. This tag helps us differentiate compounds that we can confirm versus those that we cannot. Those that don't have the item tag cannot be reported by confirmation. We can note that they were seen, but our confidence is low. If we want to report them, we'll have to get a stock in-house and update the compound item tag, retention time, and fragments with our own data. Alone, these item tags really don't do anything, but with filters, they can minimize the noise in our match list by making it easier to identify compounds of interest. So now that we have item tags, we can treat compounds differently, whether we've run them in-house or not. But in order to display that information in our match table, we need to make custom formulas based on that tag. We can use the item tag to make a quick custom formula that tells us whether or not that item tag exists or not. Here's a quick video to show you our in-house RT custom formula. I'll navigate to Administration, then Manage Custom Fields and Formulas. Then from there, I can select an already made formula or create a new one. In this case, I selected the in-house RT formula to show you that it's a Boolean formula that allows only true-false values, and that the formula is simply looking for in the item tags for the in-house RT tag using the find function. The second custom formula I'd like to talk about is the screening composite score. I have to admit, we received this formula from Waters. It included a bunch of stuff related to retention time, isotopes, mass error, and fragments, and then it assigned percentages to each of the scores so that it was out of a possible 100%. That makes sense, right? But why should we limit ourselves to it being out of a 100? This screening composite score should be our way of organizing our matches from best to worst. So I updated our screening composite score in a few ways. You can see that screening composite score here at the bottom in the formula settings. First, I always wanted to see our internal standard first. we use only one internal standard since we're really just testing to see if the injection was successful or not. Ours is warfarin D5. So let's move that to the top of the list with a simple if-then statement. If the component match name is warfarin D5, add 200 points. If not, don't do anything, add 0 points. You could use an internal standard item tag here and a different custom formula if you had multiples, or you could add each individual internal standard component to this formula in this fashion. Next, we use quality control materials in our run to create mini calibrations for analytes of special interest to us. The low concentration is pretty much a cutoff level. The high side is 10 times that concentration, so that we can see what the increased concentration would look like. I want to see those next because they're important to us. Add 100 points if the calculated concentration is not Planck. That exclamation point equals means not equal to. What about when we import a new and novel compound that might be coming around, but we don't know if we can see it and we have no idea what the retention time is? Let's put those all the way at the bottom of the list since they'll be speculative hits and there might be a lot of them. Subtract 100 for no expected RT. All right, now for those in-house RT components. These are things that we've characterized in-house, things that we can report and know that we see well. Really, these are things that we care about. The rest is just speculation, so those should be next. But I want to cut off for things we care about and things that we don't. So let's subtract 100 points if that tag isn't there. That way, a positive screening composite score goes to quant or confirm. Negative is just a tentative ID. This updated score now organizes all of our matches by internal standard first, calibrated compounds in our QC material second, then anything that we've run in-house, followed by everything else that matches without an expected RT at the very end. So now that we have those in-house RT and screening composite score custom formulas, we need to add them to our match tables so we can see them. To do so, right-click in the column heading in the match table, select Add Column. Then select them from the list on the left to move them to the list on the right. You can search the fields to make selecting easier. You can reorder the selected fields on the right-hand side to suit how you'd like them organized. In-house RT is down a little further, but it's listed on the right as well. So here we add the in-house RT column, and then the screening composite score column. Since we'll use the score to organize our data, we'll move that higher in the column list so it's more easily visible. Though we have the same number of matches, now we have them organized into sections of things we expect to see at the top, which is our internal standard, and then anything that matches our QC with estimated concentrations. Next, anything we've run in-house with interesting other stuff and new stuff at the end. You can see me scroll through that match list here. So this makes it easier to concentrate on certain portions of the match list over others without limiting the list too much. And then we would be less likely to miss something. All right, so we've sorted our match list, but we can do better. Let's add some filters to separate the matches into different classes to make reviewing and reporting easier. Let's start with a simple filter called accepted IDs. Go to Filters, Manage Filters, then Create or Modify. We want a component filter named accepted IDs. This will list any match that has a label that is not empty. All right, here's another one. Compounds with estimates. It's looking for matches with our internal standard or when the known concentration is not empty. If we pair that with a pre-made Waters injection filter of standards only, we can make a workflow step called standards check that only looks at standards and the compounds in them that have known concentrations so that we can quickly check the batch QC or standards to see how things are looking before ever evaluating any of the samples in the batch. I won't show you these other filters I've made, but you can see how it's easy to make them just to check for something like opiates or THC or all of the compounds with the fentanyl analog item tag. We also have one really complex filter, high confidence ID. I'll show you that filter on the next couple of slides because it's pretty long, and I want to talk through it step by step. All right, so here's the high confidence ID filter. It starts with a positive mode match criteria. So we start with charge greater than 0. Make another one for negative mode at the end. The positive mode, we want to see anything with 2,000 or more detector counts that wasn't tagged as excluded in the method, was identified by the Unify software, has a mass error between -10 and 10 ppm, RT and RT window of 0.5 to 14 minutes, retention time error between -0.2 and 0.2 minutes. Then we want to see any identified matches that contain saturated peaks, since we know that saturation causes high mass error and retention time issues. Separate from all of those things, we want to see anything with a calculated concentration in this filter. And then we have some compound-specific additions for morphine and gabapentin, buprenorphine, negative mode components containing carboxy, which is basically the THC metabolites, and then naloxone. And here we have our negative mode filter. Charge less than 0, 1,000 detector counts, not excluded, identified, between -5 and 5 ppm mass error, retention time between 0.5 and 7 minutes, and retention time error between -0.2 and 0.2 minutes. And lastly, we found that sometimes Unify shows an empty response value on integrations. We don't want to miss any of those. So anything that's identified has an in-house RT tag with an empty response, and the RT error is between -0.15 and 0.15, should go to that high confidence ID. There's a lot going on in there, but it really cuts down on the number of matches that we have to weed through to find the ones that are reportable. Once you've made the filter, create a workflow step, select the filters from the Select Filters dropdown, and save the workflow step. If you're using a network system, you may have to do an export-import dance to get these filters and workflows to be available to all users. You can contact either Waters, or I can help you through that if you need to do something like that. Once we've added those filters to a workflow step, we can easily apply them to our analysis. Here's a look at that same sorted match list, but using the high confidence ID filter. Now we've limited the number of matches to look through with a clear delineation between the matches that are characterized and the ones that are speculative. You can see the video pause to show that delineation. The next step is to evaluate these criteria and tighten them up to filter the list even further. Though with a constant workload, I haven't had time to do that just yet. But 167 matches is quite a bit better than 673. And they're organized by things that we care about to things that are speculative. All right, another useful tool that we've incorporated is looking for fragments of compounds in the high energy spectrum. This is especially helpful for saturated compounds, as you can see in this example for diphenhydramine. The chromatogram on the top left shows some loss of ionization, causing a dip in the top of the peak. By adding the secondary in-source fragment component, we get a better peak shape and are less likely to miss something due to high mass error caused by a saturated compound. We can also better estimate the concentration in the sample based off this response. Here's how that in-source fragment looks in the method. The RTs are the same, but I've added the formula for the breakdown and specified the adduct of a loss of an electron. This diphenhydramine example is a pretty minor example of saturation. Sometimes we'll see it where it'll drop all the way down to 0 in the middle. That's kind of the thing that we're looking for to replace with this in-source fragment. All right, let's move on to something that's a little bit less Unify related. AutoHotkey. AutoHotkey makes my life easier. It's just that simple. When I want to do a review of my QTOF data, I need a bunch of things open and I like them spaced out in a certain way. So I adapted a script I found on their forum to meet my needs. When I'm at work, that layout's different than when I'm working remotely, so I adapted it further. This saves me from opening each program separately and moving the windows around all in one quick program launch. I'll show you this in action. The code itself is pretty large and time consuming to go through all in a short time frame. We'll go over some other uses too. I'm going to run through this pretty quickly though, so please reach out if you have any questions. Here's my 2-screen layout at work. I have my Unify open fully on one screen and the other screen split between our data reporting software, an Access database directing our quants, an Excel file that tells us how we handle different drugs when they're found, and my Outlook email and calendar. When I'm at home, I have two different options. I can use my widescreen monitor with my laptop below shown here, or I can use my wife's office when she's at work and use a 3-monitor setup like this. All the same programs, just spaced out a little bit differently. All right, so let's look at AutoHotkey and using it with Unify data. We need to be able to move between samples easily and be able to put labels on a bunch of matches quickly. We can script those too. Keeping your hands on the keyboard and not mousing between samples is much faster. Not to mention that we can have it automatically go to the top of the list when it switches to the next sample. So let's look at building that AutoHotkey script. We start by making a text file and then saving it as .ahk, so AutoHotkey knows it's a hotkey file. We need a few things at the top so we can tell AutoHotkey that it can use the mouse to move around. That's the hashtag install mouse hook line. The single instance force line is so only one copy of the script can run at a time. We don't want any duplication here. And we use Windows Spy to find those coordinates by selecting it in the right-click menu on the AutoHotkey button in the Windows taskbar. Those are for the mouse and are relative to the window. Here are a couple of quick and easy commands for AutoHotkey. Sleep, click, send, and then some symbols that stand for keys that you use with other keys. Control, Alt, the Windows key, and the Shift key. Sleep waits so many milliseconds before moving to the next line. Click uses the mouse buttons. Send is for the keyboard buttons. So for this next sample command, we have the header lines to start. It then waits 500 milliseconds, clicks here, waits 900 milliseconds, clicks here in the match table, waits 200 milliseconds, then presses Control and Home to move the top of the list. Then the return in the line ends that function. For the previous sample, it's pretty similar. Waiting between left-clicking here, then here in the match table, then goes to the top of the match list. So you can see how these would be really helpful by using the Alt right arrow or Alt left arrow to go to the next sample and move to the top of the batch list, or to go to the previous sample and move to the top of the match list. Here it is in action. So I'm pressing Alt right to move to the next sample, and then Alt left to move back to the previous sample. You can see me moving down the batch list as well. So we can also use AutoHotkey to add labels to our matches. You see here a bunch of commands for adding present, NOS, TID, or removing a label from a match. They're all pretty simple, just sending a right-click command using the keyboard by pressing Shift F10, waiting, pressing down a couple of times to get into the label field, waiting, typing in the label, and then pressing Enter. Here's another quick video showing those commands in action. I'm pressing Alt-Z, Alt-C, Alt-F, and Alt-X to make all of this happen without moving my hands from the keyboard. You can see the label on the Warfarin D5 change between present and NOS to TID. And here it will delete that label. Now it'll switch back to present. We can get more specific with these commands to make sure that they only operate in the Unify window. Otherwise, whenever you press them, they'll just do the commands in whatever program you're in. So we add in all this different title commands, the set title match mode, right, regex, and after the command we type in win-activate ahk_exe waters.deployment.client.exe so that it knows to run it in that window rather than wherever you are. You can see where that'd be problematic if it was pressing tab and down, and then typing in present if you're in an Excel file. So now these allow you to press your auto hotkey and it'll jump over into Unify, then do the commands in that window rather than whichever window you're currently in. So it's kind of nice if you're working in, say, your reporting software and you want to quickly jump back over to Unify to the next sample. You just hit Alt right arrow, goes and grabs Unify, moves to that next sample, and then you're ready in the match list rather than being in your reporting window still. All right, enough about auto hotkey. Let's move on to reporting all this data. My first recommendation is to make multiple reports to suit your needs. We have 3 reports that we use regularly. A QC report for keeping logs of instrument performance that we summarize in Excel. A large report with chromatograms for a full review of all of the reported data. This one's useful for court and open records, but we don't need all of that for in-lab resulting. So we make another report without any of the chromatograms and none of the audit trail. We keep it simple for transferring this data onto forms or into a LIMS system. For a QC-only report, we set up a report similar to the standards check workflow step that we made earlier. We want only injections that are standards and components that are labeled. We then add a table with information that we can use to track instrument performance for each compound. You can see that information that we've chosen to report in this slide. Here's what that QC report ends up looking like, with components, the QC name, the analysis name, fragments, response, label, and instrument. This can be reported to an XLS file and summarized in Excel with other runs to track that instrument performance from run to run and from instrument to instrument. This is just a small snippet, a summary of just one of the QC and only 10 matches of the different components that are inside of that QC. This actual report is quite a bit bigger than that and includes all the QC from the run. All right, how about a report for just our samples without any QCs that we can use for reporting on forms and in our LIMS system? We use an injection filter of unknowns only, then a component filter of label is not empty. We can narrow down the information in the report table to just the things that we care about for this task. We don't need response or fragments since we've already labeled them as matches. So we just have the compound, the estimated concentration, the label that we've given it, and if it's a saturated peak. You can see all of these components are labeled as present, but if we had something that we called NOS, something that we wanted to put on the report, but not something that we're calling present, that would show up in here with a label of NOS. All of these do not contain saturated peaks, but if one of those was really large, that label there would say yes. And our third report. This is a big one that contains everything that we need to talk about the data. It is a full report of all of the data. It contains the audit trail for the analysis. It contains the sample list with each injection. And then it contains a match table for each of the compounds found in each sample. Then it contains the chromatograms for each of those matches and any fragments that were found. This is our open records report. It summarizes everything that's being reported from the run. It contains all of the information that we need to talk about without ever having Unify present. So that got us through our reporting. Let's talk about data storage. There are 2 main types of saved runs in Unify. There are sample sets and there are analyses. To give you an idea of storage needs, our negative method is 7.5 minutes long per sample. We run a 96 well plate plus 1 prime injection. Those runs are between 7 and 8 gigabytes exported. The positive mode run is twice as long at 15 minutes, and it's between 13 and 14 gigabytes exported. Those are just for the sample sets. If you're doing an analysis, That contains a processing method, match information, and any post-processing manual manipulations. And those are 9 to 10 gigabytes for negative mode and 25 to 26 gigabytes for positive mode. So now when you save those files, you're not overwriting them, you're creating new versions. So each of those files you make add up. The tricky part is that each full save is a duplication of those files. Every one of those versions adds on another one of those 10 gigabytes or 25 gigabytes for each of those analyses. Usually you don't make multiple of the same sample set, so those will stay pretty solid at 7 or 8 or 9 or 10 gigabytes. But every one of those analysis saves is going to be another 25 gigabytes in positive mode, 10 gigabytes in negative mode. Here's an example of an analysis that we have on our system. For this data set, if we were to save each version of the analysis and the sample set, we'd be looking at about 160 gigabytes of storage space. That's 6 analyses and 1 sample set. This is what lives online in Unify. By exporting this, we can just export the last version and the sample set. So we can trim it down to about 40 gigabytes. And then we use the audit trail with that with the sample set and with the analysis to know what was being changed in the versions that were deleted. We don't need to keep all of them. We just save the sample set, which is the raw data, and then the analysis, which contains the method and the last modified data. Up to this point, I'm just talking about online data that exists on the server or at the instrument. We can package up the data and export it to offline data that can be moved around and backed up for long-term storage. For that offline data, we have a 24 terabyte archive space that currently has just over 12 terabytes on it from 3 years of data collection. Lastly, the water server has a scheduled backup job that it does nightly and weekly to fully back up everything that's online in the database. Our Oracle server that houses that online data is 12 terabytes in size, but we only use about 5 terabytes for around 1 year of online data. Backups of that 5 terabytes are just over 3 terabytes compressed. We use an 11 terabyte space carved out just for those server backups. And all of that doesn't include the RAID arrays that duplicate these disk drives in case of disk drive failure. So you can effectively double almost all of those storage needs. All right, so here's a quick look at exporting a run out of Unify. You can see that I've selected all the sample sets and analyses for that date in the Explorer window. I then right-click on this selection and choose Export to, then Unify Export Package. That makes a .uep file for all of the files that you've selected. Once that export is complete, I'll go back into those files and delete them from Unify. The export only takes the highlighted versions, which are the latest versions, but the deletion will remove all versions. I do this about monthly, and it is a manual process. I've made an Excel file to help me track which files are ready to export or delete so that I don't delete ones that aren't already exported. But it's pretty simple to just organize them by date modified and group them together that way. That way, if you just export one, and then when it's finished exporting, you can go back in and delete it, you know that you're getting everything exported and deleted, and you won't delete anything that you didn't already export. Those exported files are standalone and can be shared, moved, backed up, etc. And they're slightly compressed to save some more space. The only drawback is that you're not immediately available to look at them in Unify. You'll have to import them back into the system to do so. And that takes quite a bit of time, just like exporting does. I think it's around a few hours to export or import any one of these multi-gigabyte files. The nice thing about the import process is that it does give you a countdown timer of until how long it's going to take until it's finished, where the exporting is kind of like a percentage, and it doesn't really give you an idea how long it's going to take. Hopefully, if you're not using the Waters instrumentation or Unify software, you're still able to use some of this in your daily work. If you have any questions, please feel free to reach out. My email address is provided in this slide. You can contact me through that.
Thank you, Ryan. We will now hear from our final presenters before the afternoon Q&A. Dr. Michael Truver with the University of Florida, and our very own moderator, Dr. Josh DeBoard with the Center for Forensic Science Research and Education.
Good afternoon. My name is Michael Truver, and I will be giving a talk on Advanced Applications Retrospective Analysis. I am a paid employee of the University of Florida. I have no conflicts of interest in the material of this presentation. The speakers have received an honorarium for participating in the webinar. This webinar is not sponsored by any of the instrument vendors mentioned. The University of Florida Forensic Toxicology Lab is a postmortem toxicology lab that serves 5 medical examiner districts within the state of Florida. 15 counties reside within these 5 medical examiner districts, as you see with the blue borders in the image on the slide. We receive between 2,500 and 3,000 cases a year, and we also receive less than 5% of cases that involve referral testing. Our lab has a total of 8 employees consisting of our director, myself, the deputy director, 2 chemist 2s, and 4 chemist 1s. Our laboratory has historically been mainly a GC-MS lab. For our presumptive screening, we use an MGC 240 system using CEDIA immunoassays. These screen for amphetamines, benzodiazepines, cocaine, opiates, and THC. We use Headspace GC-FID for volatile screening and confirmation, and we use GC-MPD and GC-MS for our comprehensive drug screening. After screening, we confirm using GC-MS. Additionally, we have a Waters LC-MS that is used only for research at the moment, and we have an adjuvant QTOF that I will talk about further in our next slide. We recently moved into a bigger building and acquired new instrumentation, including 2 Orbitraps and 3 Thermo Fisher LC-MS. Our goal for the coming years is to transition our methods to these newly acquired LC systems. Now let's get into our QTOF screening. As previously mentioned, we are mainly a GC-MS laboratory, but we are fortunate enough to acquire an adjuvant 6545 several years ago. When I first started at the lab about 2.5 years ago, there was a method on the QTOF used to screen for carfentanil cases. The panel consisted of 8 fentanyl analogs, including carfentanil and fentanyl. During this time, fluorofentanyl was just beginning to reemerge in prevalence throughout the country. One of my first tasks was to use retrospective analysis to presumptively identify if previous cases had fluorofentanyl or xylazine present. After this observation was complete, we revalidated the method to identify fluorofentanyl, xylazine, and 14 other fentanyl-related drugs in urine. Cases are reflex to this method if the history includes any type of drug overdose or mentioning of drug paraphernalia, including spoons and syringes. This method consists of a general mobile phase of 0.1% formic acid in water and acetonitrile. We use an adjuvant Poroshell C18 column to achieve separation, and the gradient goes from 90% mobile phase 8 to 50% over 7.5 minutes. Currently, this method is only using the time of flight without enabling the quadrupoles. We use UCT's DAU columns, and we only collect the basic fractions since these are copolymeric columns. For data analysis, our acceptance criteria is the compound identification score on the qualitative report for the analyte and internal standard must equal to or exceed 75 with consistent mass to charge ratio, and retention time. Additionally, the weighting we use is 100% on the mass score, 60% isotope abundance, 50% on the isotope spacing, and 100% on the retention time. From this method, I routinely check for compounds that are out of the scope of our testing. Any QTOF platform should be capable of retrospective analysis, but for my talk today, I will be focusing on the adjuvant perspective. Adjuvant has a personal compound database and libraries, or PCDL, which allow users to search by formula, accurate mass, and retention time. The use of retention time increases the compound's identification specificity. Our laboratory uses the scope recommendations from the Center of Forensic Science Research and Education to try and keep our PCDLs up to date with newly emerging NPS. We focus our libraries on novel synthetic opioids and designer benzos, mainly because we don't have issues identifying stimulants by our drug screen currently, and synthetic cannabinoids are complicated compounds that, for now, we only send out if the medical examiner indicates suspected use. The criteria from our SOP for data mining is, at the discretion of the analyst, a case may be further investigated using the exact mass analysis for the presence of substances that are not routinely detected. The exact mass screening is presumptive, and therefore confirmation testing would be required. Next, we will go through 4 different cases that have benefited from the use of data mining with PCDLs. Our first case involves a 37-year-old white male. He was a sales representative on a business trip who was found dead near some drug paraphernalia. Our immunoassay results were negative, and our comprehensive testing resulted in 0.2 grams per deciliter of ethanol and less than 2.5 nanograms per milliliter of fentanyl. Although we could see this compound through our base screening techniques due to its great abundance, I wanted to include this to show the chromatography that we observe when we have metragenine positive cases. For metragenine positive cases, there are usually several peaks that elute after the metragenine peak. These are most likely due to the other alkaloids associated with metragenine. From this chromatogram, the metragenine peak is exponentially greater than the internal standard peak, that is shown bracketed by the black dotted lines. After observing this, we decided to send the case out to NMS for confirmation of metragenine. The NMS report was 550 nanograms per milliliter of metragenine in blood from this case. Our next case involves a 44-year-old white male. The decedent had a history of drug abuse and green foam was present. The medical examiner indicated that drugs they suspected were methadone, oxycodone, and K2. Our immunoassay results were benzodiazepine and THC positive. Our comprehensive testing resulted in 67 nanograms per milliliter of alprazolam, 0.12 milligrams per liter of methadone, and 20 nanograms per milliliter of fentanyl. Additionally, since the medical examiner indicated the possible K2 abuse, a sample was sent to NMS for synthetic cannabinoid testing. With the identification of alprazolam, the presumptive screen positive for benzodiazepines was confirmed, or so we thought. This is a screenshot of the benzodiazepines that were identified in urine through our out-of-scope PCDL. The decedent seemed to have an affinity towards the designer benzodiazepines. There were 5 possible designer benzodiazepines, including hydroxyatizolam, metizolam, istazolam, etizolam, and flualprazolam. Traditional benzodiazepines were also identified from our library. Here's a chromatogram for case 2. As you can see, the hydroxyatizolam is in great abundance compared to the internal standard. That is again bracketed with the black dotted lines. I also have labeled peaks for the etizolam, hydroxyalprazolam, alprazolam, and flualprazolam for comparison. Here is the recap of the results that we determined from our comprehensive drug screen on the left side of the screen. Since we already had sent out the blood for synthetic cannabinoids, we were able to add additional testings for the designer benzodiazepines. The NMS report for synthetic cannabinoids was negative. The results for the designer benzodiazepines was 9.7 nanograms per milliliter of flualprazolam, 37 nanograms per milliliter of hydroxyatizolam, and 120 nanograms per milliliter of etizolam. The metizolam and istazolam were not confirmed due to being out of the scope of the NMS designer benzodiazepines panel, and therefore they were not reported. Case 3 involved a 25-year-old white male who was a meth user. The medical examiner indicated drugs suspected including methamphetamine, other fentanyl, and opioids. The immunoassay results were positive for amphetamine, benzodiazepines, and THC. Our comprehensive testing resulted in 2.5 milligrams per liter of butalbital, trace amounts for dextromethorphan, 0.56 milligrams per liter of methamphetamine, 0.14 milligrams per liter of amphetamine, xylazine was present, and 31 nanograms per milliliter of fentanyl. After reviewing the results from our testing, it was observed that the presumptive positive for the benzodiazepine was not confirmed by our confirmatory testing. Through our out-of-scope benzodiazepine PCDL, we identified hydroxybromozolam and bromozolam. From the chromatogram on the right, I wanted to highlight the chromatography that is sometimes observed for our out-of-scope compounds. Since the method is not optimized for these compounds, the chromatography is not always ideal. For bromozolam and hydroxybromozolam, they have peak tailing, but this is also observed for other benzodiazepines, such as alprazolam. Over the past year, we had seen an increase in the prevalence of bromozolam and other designer benzodiazepines, and therefore developed a confirmatory method on GCMS. Using this validated GCMS method, we determined that there were 30 nanograms per milliliter of bromozolam present in the blood for this case. Finally, case 4 involved a 29-year-old Hispanic male. The history only provided drugs that were suspected, which included an abundance of drugs such as amphetamine, benzodiazepines, cocaine, fentanyl, heroin, mushrooms, and opiates. Our immunoassay were only positive for benzodiazepines. This is one of our current cases, and therefore testing is still in progress. But for our pending toxicology findings, we have norfentanyl, fentanyl, and hydroxyalprazolam present in the urine. Since the medical examiner included numerous drugs of abuse, we wanted to ensure that we did our out-of-scope analysis. We were able to identify 8-aminoclonazolam using our designer benzodiazepine PCDL. Since this is a pending case, the blood has been scheduled for confirmation for fentanyl and alprazolam. Clonazolam and 8-aminoclonazolam were not included in our validated method for the GCMS for designer benzodiazepines, and therefore we sent this out to NMS for a designer benzodiazepine confirmation. In conclusion, retrospective analysis is a valuable tool for identifying drugs that are out of scope of testing for routine analysis. Through retrospective analysis, I was able to identify and improve our initial fentanyl analog method by including newer drugs that were emerging. Using data mining and/or retrospective analysis is a necessity to help identify NPS since they are ever changing. Thank you. And now I'm going to pass it over to Josh.
Okay, thanks, Michael, for that great first lecture. My name is Josh Udebord. I am a senior scientist at the CFSRE, and I will be closing out our session with a discussion of a more advanced screening technique, which is the screening for neutral losses and common fragments, which relies on one, either commonly generated daughter fragments in the case of common fragments, or in the case of neutral loss, the difference in mass to charge between two charged ions associated with a particular compound. Usually that is the difference between the parent and the daughter ions. And the chromatogram that I've shown down below is the extracted ion chromatogram that everyone would hope to achieve from employing a neutral loss and common fragments workflow. Here is my disclosure slide. Summarily, I don't have any conflicts of interest in the material given. To begin with, I want to discuss the main challenge one might be trying to address with the common fragments and neutral losses screening method, and that would be NPS or just a general unknown. So NPS obviously are challenging class of targets because by the time a lab has sufficiently validated a method to identify them, perhaps they may no longer be observed in the market at all. So it would be perhaps a waste of time and investment to pursue a fully validated identification method for an NPS. Neutral losses and common fragments can actually offer a flexible means to screen for those without fully validating a method, although, because it's not held to the same rigors as a fully validated method, one's internal policies would have to stipulate to what extent, if any, the results of this screening method would be reportable. It's mostly there to identify an unknown and provide a secondary layer of security when the initial assays results perhaps don't explain a death, for instance, in a postmortem investigation. So I'll discuss an introduction to what neutral losses and common fragments are, and provide a nitazene analog as a example and relevant structures to designing an assay around that. And then I'll present just briefly a neutral loss and common fragments table that myself and colleagues at the CFSRE have developed to assist in identifying substances based on their neutral losses and common fragments. I'll make some general recommendations for incorporating neutral losses and common fragments, some basics, and then offer some specific targets for nitazenes as an example, and provide a casework example. So some of the challenges within PS would be that they are outside of your scope. You, if you're an international lab, may have limited available standards. They may be infrequently or only occasionally observed and then completely absent from casework. And so therefore it may be costly and impractical for your lab to update full capabilities for identifying NPS. So what are neutral losses and common fragments, and how can they help you with that problem? So we'll start with common fragments, which are isobaric fragments that are generated from a compound of structural similarity, which include NPS classes of nitazene analogs, synthetic cannabinoids, and fentanyl analogs. I'll present etanitazene as an example, which is a fairly uncommon nitazene analog, but it shows some very common fragments, which is the triethylamine fragment. Nominal mass of that is 100 Daltons. And the associated neutral loss is simply the inverse of that. So what is the neutral loss associated with the formation of that fragment? Most of the time, such as in this case, they're easily predictable, but they often, I should say occasionally, are not a single structured loss. So they, you can't really conceive of them as an intact structure. But in the case of etanitazene, the generation of that triethylamine is the result of the neutral loss of this core structure with a nominal mass of 297. This table is probably one of my favorite tables. Every scientist has one of their favorite Excel spreadsheets. This is one of mine. This is generated from our SciEx swath library that Alex Grotulski and Sarah Walton, two of my colleagues, primarily populated the data. And I noticed that this data could be used to help us predict neutral losses from these, and also to consolidate the common fragments produced and help us to target the most valuable common fragments and neutral losses for screening certain compounds within each of these classes. And so the highlighted example here is showing etanitazene and how it's the molecular weight of 397 when protonated, the common fragment of 100. I round them to 2 decimal places so that all of the fragments, will bin together, and you can see the neutral loss of 297 is shared for quite a few of these different nitazene analogs. I'll show another example later in the slides for isotonitazene and its protonated molecular weight of 411. May be helpful for you to file away for a future slide. So now we'll cover some structures relevant to neutral losses and common fragments. So for the nitazene, sticking with that example class, I have here highlighted etanitazene, and you can see that there are 3 relevant neutral losses one might target for nitazenes. The most common are the 311 and the 339. As I mentioned, etanitazene is not a very commonly observed analyte, so the 297 qualifies as a secondary target, whereas the 311 and 339 would be the primary targets for neutral loss incorporating nitazines. And you can see that, as I mentioned, the core structure can change varyingly in how the molecule is arranged, and the isobaric similarity remains the same, which is why it's useful for screening a wide assortment of compounds within this class. The common fragments are typically attached to this triethylamine here, and here. This group is typically what is formed for the common fragments, and depending on what nitazine analog is being targeted, would relate into a differently formed common fragment. Some guide on implementation. How can we get a successful implementation of neutral losses and common fragments? Well, if you're attending this webinar, you're already halfway there, because implementation is got a huge leg up by using QTOF technology. You can do this with a triple quad, but the information from nominal mass is much less informative than what you get from a high resolution tandem mass spec system. You'll need to have mass spec parameters where you can associate the parent and the daughter. I know the scan modes will be covered in another lecture, so I won't talk about too much of that, but you need to be able to associate a daughter to a particular parent ion to be able to appropriately calculate the neutral loss. And that's not always the case for certain non-targeted scan modes. So I will show you some recommended targets for this, top tier targets for general use, and depending on your, the compounds you may see in your local casework, you may need to incorporate secondary targets as well. Depending on the matrix chosen, you may even incorporate metabolic targets. So if urine is the matrix, then a neutral loss of glucuronic acid would be an ideal target. The neutral loss associated with that is 194.14 rounded to 10 millidaltons. So that would be the target used for detecting a glucuronic acid neutral loss. So if a urine matrix is appropriate, that may be a good workflow as well. The purpose of neutral loss in common fragments is really to identify an unknown peak as a potential unknown or NPS with these mass filters, and then to further investigate that mass, possibly elucidate the structure, but it is not sufficient for identification, merely to allow the possibility to identify the unknown and then to perform further investigation on that. These would be some of the primary targets I would recommend for nitazine neutral losses in common fragments. Predominantly, they are associated with the triethylamine loss and the core structure resulting from that loss. There are some secondary targets where if you have some more esoteric nitazine analogs in casework, maybe they would be appropriate to set up in the mass filter as well. So I'll give one case example to close it all out. Here I have an unprocessed chromatogram of a sample that I've spiked containing isotonitazine at 20 nanograms per mil. I've set up in this window a neutral loss and common fragments filter at 20 millidaltons, which is typically what I use. Our instrument generally performs at about 5 ppm mass error for our standards, and if that's how your instrument typically performs, that should be suitable. If you're running 10 or greater ppm routinely, you probably have some other issues with your instrument you need to sort out, but also expanding that threshold to maybe 30 or 40 millidaltons might be appropriate for that situation. But when you run this mass filter, I only get one peak identified for sharing the common fragments of 72 and a 100 nominal mass, obviously rounded, and the neutral losses of 311 and 339. And so that is the peak for isotonitazine. Then once that peak has been identified, you can then investigate the mass spec and the MS-MS to identify what could be the molecular weight of that ion. So here at the 411.23, we have the molecular weight of isotonitazine. When I look at the experiment associated with the MS of that 411, I see that I'm generating a 100.11 Dalton fragment, which is associated with that triethylamine loss. And then the calculated neutral loss of that is 311.12, which is associated with the shown core structure neutral loss. So this was the slide that I presented in a related talk at SOFT in 2022. And I'm proud to say that we are actually going to deliver on one of the promises actually that I made in one of the final slides. Almost nobody ever really gets around to actually delivering on this, but there is a toolkit in progress that will further build out some guidelines and suggestions for incorporating neutral losses, as well as all of the other topics that have been discussed in today's webinar. It'll also cover the tier 1 and tier 2 recommendations for fentanyl analogs and synthetic cannabinoids, as well as the ones that I discussed here in the nitazines. So with that, I will open up for any questions for the remainder of the webinar, and thank you for your attention today. If anybody needs further information, the toolkit will be available shortly, and you can reach me at this for any specific questions. We will go ahead and jump into the afternoon's Q&A. Thanks very much, Kristen, Ryan, and Michael, for contributing your knowledge to this afternoon's session. Allow me to welcome the presenters to the Q&A. And as before, I'll do my best to ask the questions round robin style. I'll first direct it to someone, but feel free to jump in with your thoughts on any questions that were directed to another panelist. All right, I'll first direct kind of a general question to everyone, and just start maybe with Michael, since you're maybe newer to transition over to a QTOF, but what has been your experience with using a QTOF, and do you enjoy using it, and would there be anything you would change about it if you could?
That's a loaded question. So my experience with the QTOF has been a little bit up and down. I listened to the panel discussion earlier, and I kind of agree with what Danny had said about, like, if you don't have someone in your lab that is able to work on the QTOF itself to bring it back up to what you want, it kind of acts like a paperweight. So right now we are at that point. That's why we only have one assay on there. We have the fentanyl analog assay that I helped bring up whenever I was a postdoc here, but right now we don't have anyone who has time to devote to the QTOF to get our comprehensive screen on there. So it's good as far as, you know, able to detect NPS, because without that, we wouldn't be able to identify the compounds that I showed in my presentation. But again, we're not using it to its full capacity.
How about you, Kristen?
I would definitely say that I completely understand where Michael is coming from. And part of my presentation, I mentioned that we have the 6445 Agilent, like what Michael is using. And we have had that for a little bit of time, and it has taken us a long time to start to get our methods moved over. That said, we have our other one that we are using regularly. There's a lot of intricacies with the QTOF and TOF, and it really can be great. And I feel like I'm copying Michael, but it's great for NPS. And I'm sure of the Q&A from earlier, but it's great for NPS, and it's done. We've done a lot with it, and it's done really well for us. But these are complicated instruments, and I would say even software is a big hurdle too. For us, it's been a little bit about software. We're like, okay, we understand the theory, we understand the instrument itself, but some of the intricacies of the software can also kind of slow you down, or at least that's been our experience.
Yeah, Ryan, since you've been using from 2019, you're like one of the OGs, so let's hear it.
Honestly, you guys got it all right. It takes like a good year just to get it under your belt and figure out how to use it. And you know, from there it's building on what you have. So you're constantly adding to it, you're constantly putting more compounds into it. What was the biggest shock for us is we went from an enzyme immunoassay and a basic screen, and we didn't know how much stuff we were missing. You turn on that QTOF and it's just an explosion of all these new drugs that now you got to look at confirming them, and all these fentanyl analogs that you never saw before, and the nitazines, and it's wild. But like Kristen said, the software is really a hurdle, and you need to be able to dedicate somebody to really dig into it and be your point person that is spending almost all their time on it, just to make sure that your lab is staying on top of it and not falling behind on where you need that QTOF to be. If it's directing all the rest of your testing, you got to be on top of it.
Yeah, I completely agree, and you clearly are one of those people at your lab. And I would just say that, you know, any system that is of this complexity, you know, is kind of like, you know, Prometheus being like gifted sort of like godlike powers, and you know, you don't really know quite how to use it at first. The capabilities are way beyond what you're prepared for, you know, as an inexperienced person. But, you know, given the right opportunity to really become comfortable with it, you know, from my perspective, you know, I've been using QTOF since like late 2018, and I still feel like there is untapped capabilities there that even we're not using, you know, in a research setting.
No doubt.
But from a process related lab, you know, the headaches that can come from it, you know, should not be underappreciated. So it is a blessing and a curse to have such grand capabilities. So that's my way of asking myself and answering that question. We'll go over to Kristen for the next one. Let me see. You mentioned that you have an LC triple quad. So what was your motivation, or if you know, what was the motivation for using the QTOF for your targeted assays?
Yeah, so we've had our 6530 QTOF since I believe 2014 or 2015. But the motivation for getting the QTOF is the sensitivity and the accurate mass. And the reason that we continue to build methods on it goes a little bit to how we like to have assays in our lab, where we don't like to overload certain types of instruments. So we said, you know, the assays that we have on here are a lot of our NPS, we have isomers. We think this would be really good to put on the QTOF. And also let's balance out, let's not overload our LC triples or even our GC triples. So we decided to put methods on the QTOF. And then when we recently purchased our second QTOF, that was, again, due to the sensitivity. We saw what we were getting from our first one, and we said, okay, this is an older, he's our workhorse, but he's an older guy. So let's get this newer one, a larger flight tube, but better sensitivity. And that's why we're trying to move all of our confirmatory methods on there. So really the high resolution is a huge reason, and its capabilities, but also we just like a little bit of diversity in our lab. So that's definitely part of it.
Yeah, and if you've got a robust system that's cranking well for you, you know, that makes perfect sense. Do you, you mentioned that you have, that your positive and negative controls assess your, you know, daily instruments performance, but do you have any mechanisms in place to monitor kind of the instrument's performance over time?
Yeah, that's usually, we do have our QC batches. So in our laboratory, we have a way to track how QC is looking over time. But as far as actual instrument, we have a log for every one of our instruments where we record things like tuning abundance, our background noise. I'm trying to think of some of the things on there.
Well,
The
really what I
HPLC.
was getting at was the QC
Oh.
performance to begin with, because in my experience, that has not been a feature that's been readily available in software. So I was curious as to your solution for that.
Yeah, our solution is Excel. We have an
Okay.
Excel monitoring sheet, and they are reviewed monthly by myself or the QA/QC person, which is me, but myself or our director. We review them monthly to look for any trends. So it's very easy. It's a little bit cumbersome, but everyone pretty much knows how to use Excel. And we kind of put all the information side by side, so we can very easily see any trends if there's the same compounds missing, or we're continually having several missing. We were able to see that, and visually it's very easy to look at.
Ryan, do you have some mechanism for that?
Yeah, we use Excel too. Like you said, it's just easy and familiar. We do a little bit of like VBA scripting to get stuff into there, so it formats it a little bit easier to read. And then we got into pivot tables and using slicers and stuff like that, so it's easier to break out for certain compounds that are having trouble. You can look at them easier than making multiple tabs and flipping through a whole bunch of different things. But yeah, it's all Excel.
Yeah, that's been my experience as well, kind of needing a custom approach to that, although it sounds like we've all sort of come to the same approach. Michael, this next question is directed your way. So once you've gone back, and I suppose retrospective analysis and also off library, whether it's retrospective or just later the same day kind of analysis, the same applies. But what's your process for then going back to verify those compounds, or do you do that?
It depends on the case. So right now for our out-of-scope, like I mentioned about the designer benzos, so we monitored them for a while. And once we saw that we were seeing bromomesolam that was pretty much prevalent in every batch, that's where we decided to develop a confirmatory method on GCMS. Like the 8-amino that we just saw in the current case, we hadn't seen it before, so we didn't include it in our method. And so now it's another analyte that we're watching the trends for. And if the case only had that NPS in it and we didn't have fentanyl or anything else, then that would make us more likely to ask the medical examiner to send it out for confirmation. But if we have fentanyl at a concentration, that's usually what the medical examiner wants.
And is that out of scope library based on a product ion library match, or something more like the common fragments or neutral losses?
We're just using TOF, so it's just that.
Oh, just TOF. Okay.
Yeah.
So HRMS of whatever the set collision energy spectrum turns to be. Okay.
I did have a question for, I guess, all of y'all. Since I did mention that we acquired this instrumentation, the Thermo Fisher LCs and the Orbitraps, well, we have a method on our Agilent, but now we have 2 Orbitraps. So we're thinking, should we pursue our comprehensive screen on the Orbitraps or continue with Agilent? I myself have no experience with the Thermo Fisher software, so it's a give and take on that.
Yeah, I've never used an Orbitrap, but I have enjoyed using Thermo instruments in the past. You might be breaking new ground for forensics there.
And go ahead, Ryan.
Thanks, Kristen. I know I talked with Thermo at SOF this last year, and they're very excited to get the Orbitraps into the forensic space. So I think you probably get a lot of help with Thermo from, if they want to be in it, they're going to help you as much as they can. But also when we first got into our waters space, Amy Miles, my director, got together this waters user group for everybody that's using waters and the software and the instruments and stuff like that. Setting up a user group like that has been insanely helpful, not only to us, like as early adopters, but then also continuing education of people asking us questions that then make us revisit the way that we're doing things and then improving on the testing that we're doing.
Yeah, 100%. If there are labs that, you know, someone is working closely with that you want to share data with, it's, you know, it's behooving to ask what, you know, systems they use, because it really is going to facilitate sharing of data and just collaborations to be on a similar platform. If you have no other reason, you know, that's a good reason as any.
Right. And I was going to say, Michael, I am not going to, on this live webinar, throw anyone under the bus. However, I was just speaking with someone in a Florida lab who just finished validating their Thermo Orbitrap for screening. I'm not sure if it's a targeted screen or just like a TOF kind of accurate mass. I don't know much about Orbi, so however, offline, so I'm not throwing anyone under the bus, I can give you that information. So maybe, and obviously we can discuss as well a little bit of pros and cons from Agilent side, but kind of as Ryan and Josh reiterated, you know, groups can help. I think we're all learning, and there's a lot of different instrumentations and way to use software. So I think groups, and this goes for anyone, right, who's watching this. We have all of our contact information, I think, have been in the slides and with this program, so definitely reach out.
Yeah, especially if you're on a platform that someone has spoken about, you know, we kind of everything, a lot of these solutions, you know, feel like you might be the only lab to encounter it, but everybody at some point does. And as you've heard, kind of develops their own unique solutions for addressing that. And sort of to that end, let me ask a general question to the rest of you, to everyone again. You know, how much has IT been needed in the involvement with your QTOF? You know, Ryan's presentation kind of brought on a lot of memories for me of when you're having to like engineer these sort of systems to use the instrument that you've just purchased. But how much can that be done by the scientific staff, or what needs outside IT help?
I'll go first on this. So when it comes to using the instrument and understanding more about the software and the capabilities of the instrument, my lab actually paid for an Agilent trainer to come in for, I believe it was 3 days. So if laboratories are able to do that and you're able to get in touch with your company, recommend doing that, because they were a wealth of knowledge. And this was someone who works a lot with method development, and it was great. On the flip side, there was something like custom reports that Agilent allows for just the reports. I had them up in my presentation. That was all made by yours truly. So there's a lot that you can do. So when it came to reporting, they had like very minimal directions. I had to Google a lot, but once I got it down, and I could use some of their templates and I was able to modify. So I want to say that it really depends on the platform and the vendor, what they're either willing to offer for free or what webinars they might have, versus what if a lab can bring somebody in. And I also think that it really does depend on what you're able to customize from the vendor and how comfortable you feel. It took me probably 2 days to figure out the reports. I mean, like almost 2 full working days. I'm not saying it was easy. And there's still things that I'm like, oh, there's one thing I want to go back and tweak. But if someone has the time, I'm sure that someone could figure out a lot of stuff. But when it comes to using the instrument
Said
or
that about
using
so
the
many things.
software, what?
I've said that about so many things, and yeah, I've recently had to customize an Agilent report. It's not easy. It's not a trivial thing to really consider what aspects of the QTOF data would be most important for those results, and then making your reporting software translate that to a report. So that is something that can't be underestimated. Ryan, one thing I really enjoyed about your presentation was like how in depth you got into some of the customized data fields, and you know, with the complexity of this data, you really do need to be mindful about reducing the amount of things that need to be reviewed by the analyst. And so you had that in-house retention time field. Could you not make that an in-house retention time relative error field and incorporate a few more points of data in that? I know we kind of
Yeah, for sure.
had discussions about this in the past, but
Yeah, honestly, like all those fields, you can make them as deep as you want and get as involved in you want. I will say, reach out to your colleagues. There's people that have been doing this, and the forensic community is just phenomenal with sharing all of their stuff. Ask for reports and stuff like that. I'm happy to share whatever we have. I don't know that it's going to work for everybody, but at least gives you a starting point of seeing what other people are doing, and then kind of manipulate it and ask questions. Come back to people and just say, hey, I just want to change this one thing. How do you do it? And it's going to take them 2 seconds to just tell you, like, click here, change this, whatever, and then you'll be fine. But all those little learning processes, I don't think anybody's going to be able to do a full presentation like this or present on it at Soft or anything. But you ask them through email, you know, it's 10-minute back and forth and you're good to go. So keep that in mind.
yeah, you kind of drew the short straw on presentation topics, but I think you handled it very well, because it's important for you know, someone considering a QTOF or in the early days to know, you know, just how deep down the rabbit hole, you know, you know, you need to think in order to really maximize, you know, what it can do.
So coming back to the original question about how involved you need to get IT in, like doing this setup and working with you to keep your instruments online, this data storage on these things is just insane. And I don't know enough about the hard drive spaces and networked instruments and the tower that they use for the server and all that stuff. We're getting into moving from our Unify onto Waters Connect. So we had to buy a whole new server and move to get that working. So you're going to have to find somebody within your IT staff that you're really comfortable working with quite a bit to make sure that you have the space available and that you're catching it. If you are starting to fill up, that you're catching it before it becomes like this end all problem where your instruments are now no longer running. So we've had that happen a few times with Unify, and man, I hope when we roll up Waters Connect that we don't run into those same issues. But again, make sure that you're conversing at least and monitoring that kind of stuff.
Yeah, I think maybe even from a vendor standpoint, the requirement of many forensic labs of data storage and long-term data storage might have been not fully considered. But Kristen, on that topic, do you have, or Michael, I mean, I can't really answer, and I don't know how much data you have yet, Michael, but from a research standpoint, we don't have to store our processed data. So that's how we get around, for the most part, our data storage concerns. We mostly store unprocessed data. and then just rely on our analysts to reprocess it, because in very few instances we run probably 100, 150 cases per year. I could be wrong with that, but there's few samples that we need to store long-term processed data for auditable data. So largely as a research institute, we kind of get around that. Kristen, what's your experience been like with data storage?
That's always a struggle because the data is huge. And I did want to actually say, because sorry, I'm going backwards a little bit. IT is not really involved with our laboratory, even though I work for a large university. We try to have them be hands-off because they like to try to force other things. So I will say that while I mentioned before, ask Agilent or ask your vendor for help, IT does not really help us. So I did want to kind of answer that part of the previous question. And that still rolls into this one. We have the University of Miami, we have cloud storage, Box, Google Drive. So we actually will every month for all of our instruments, but it's really important with our QTOFs to pull off the data, zip file it, and put it onto our cloud storage, which has been certified by and we don't have a maximum. And we're able to pretty easily pull that on and off, but we have to get it off our computers. We fill up storage so quickly, and we need a way to basically indefinitely store it. We do have a few external hard drives that are like several terabytes large. That's also, that used to be our temporary before we really picked up with our use of it. So external hard drives, if organizations have cloud storage, especially if it's kind of unlimited, that's been the saving grace for us.
Nice. Michael, will have you maxed out your data capacity yet? And if not, be aware.
We use an external hard drive, so we offload that probably every quarter, but we haven't exceeded that since I think we've been using the QTOF regularly for about almost 3 years. But yeah, we haven't maxed out that yet.
All right, Kristen, just some sort of nitpicky type of questions that I had, but when you were running the blanks that bracket your casework samples, do you run those on the same LC method, or do you have maybe like just a cleanup method that you run those blanks on?
It's the same method. It's
the same. Earlier, we got a question that we didn't get around to asking, but I think you might be a good candidate for it. It was for ASB standard 98, section 45, which speaks to the threshold of 50% relative abundance of the base peak being used for acceptance. Have you had any experience with, problems with that from your matrix blanks, or and if so, what it was done to remedy that?
It's kind of difficult. I would say that we probably have had some issues. I can tell you that we've had some issues where it's not even been 50%. But especially with our targeted methods where we're looking at that MS spectra, and then we have the additional library score. When we have an extra peak, an extra mass there, right? That can severely impact our MS score, and even like our isotope scores that it uses, or isotopes that it takes into account, and we will get a very poor score then for that, which will affect our library score, which means that our library score will either be too low for reporting or won't really populate at all. So that's where we've seen it. Which then leads to not being able to report a compound. The way that we've kind of can remedy this is, one, we're taking a look at our matrices beforehand. We're taking steps to keep our QTOFs clean, best as possible. So we reduce background noise. For most of our types of compounds, we do have other tests. So if we think that we're getting interference and we're seeing that, we would then look to see if we'd be able to detect this in another method, and run that method again, or see what we can do, but it might come down to not being able to report it, unfortunately.
Okay, let's go see if we've got some chat questions. All right, here's a good one. So based on your experiences, should labs budget for extensive staff training and a long implementation period in addition to the purchase of the instrument itself? Yes, I think a resounding yes from everyone. Yeah, that's a very important thing, and for sure use it as a point of negotiation with the prospective vendors when you're looking to you're looking to be wooed into buying one of these instruments. Certainly staff training is something that you want to get plenty of. Anyone else with their particular experience?
Yeah, I know Kristen mentioned it, that they had somebody come out from Agilent that was there for 3 days on site. We had the same thing with Waters, and man, I cannot imagine undertaking all this without that 3-day training. And ours came out, we had negotiated that they would come out twice. So they came out the first 3 days and we kind of went over like background of the instrument and how to clean it and what we should be doing. And then they gave us a couple of months of using it and then came back out for another couple of days. And then we kind of dug in on the things that we really needed to talk about. And yeah, I felt like those 2 training sessions, the one to familiarize yourself with the instrument, and then the second one to like iron out some extra processes and really get hands-on with things that you've already worked on, were imperative to helping us with the success that we've had on actually getting that screening procedure rolling. But still, you really do need to, don't just dedicate someone part-time to this, like really have them focus on it. And they got to be, this is their main goal, is getting this instrument up and running. If they have other things going on, it's just not going to get there.
I did want to add too, I don't think it's any cheaper really, but for example, Agilent also has training where you can go to them. At one point it was virtual or hybrid. They might still be doing hybrid, but you can also go to them. It's not as in-depth, but you'll definitely cover the basics. We had someone who did that when it was hybrid, and they actually found it really useful. And then you get all of the manuals and you get like the presentations. So we share those as a lab. So we have the one person who really went to this training, but then you can share it with your colleagues. They don't want you to go outside your lab, but we all know. So there's options of bringing people in, sending people out to training as well.
We had something similar with SciEx instrument too. So
we had a question about instrument to instrument data comparability. I don't know if anybody has instruments from different manufacturers, any QTOF instruments from different manufacturers in the lab. Yeah, that's going to be a tough one to answer. I know across vendors, the data is basically going to be a non-starter. I don't know. I don't know if I even have the bravery to call up Agilent and ask if I could load a Waters batch on their analytical software, but no, I wouldn't imagine that's possible.
Michael, you can jump in and do something for us when you get that Orbitrap online.
Yeah, it'll be the first thing I do.
He'll make a dump on QTOF webinar right after this. So yeah, there was a comment also about service contracts. I don't know if anybody's had a negative experience with having a service contract outside of the price, but I think largely, there will be always something that you can't have someone in-house do, and it will be the most expensive thing that will happen. Anybody got a horror story they want to share?
We really haven't had anything yet with our instruments. I mean, knock on every piece of wood we can find, right? But really, the 1 year of maintenance that they include with a instrument sale is just, that's to get you through the break-in period. It's it's not going to get you very far. So at least for the maybe the first year after that, if you have somebody that's really knowledgeable with instrument maintenance, or you know a lot about the LC side, and then maybe the top side is something more thrown in that you're just working on the detector, I think maybe you'd be okay. But I don't know how many times we've called up service and have needed to use them to get ourselves back online. It seems like instrument manufacturers are getting a lot better at making their manuals a lot more user friendly, where you can do a lot of things yourself, or at least attempt it. And the instruments themselves, or the instrument manufacturers too, when you submit a ticket, they try and have you help them out, like was talked about this morning, where you can walk through the steps and see if you can get it back online yourself without having somebody actually visit you. And they'll send you parts and stuff too. So I feel like we're getting more to that part where it's a little bit more, you can do it, but you still need that service contract. When these things go down, they go down pretty hard.
The one thing I will say, that when working with the Waters instrument, we have one for research, is that it's more user friendly for like maintenance. Like it will give you an interactive panel that you can look at, and it will tell you what to do. As far as with Agilent, there's only certain parts that it will give you a walkthrough, but it's never the thing that you need.
And that might be model to model, I don't know. But in my experience, it's generally been the LC components to the QTOF that require most of the attention. At least in my experience, our QTOFs have been pretty resilient.
The routine maintenance is something that you really need to keep on top of. We started off with like the front end cleaning being like yearly or something like that, or every 6 months, and now it's almost weekly that we're doing cone cleanings, and keeping that front end really pristine is just, it's huge.
Yeah, especially thinking about these types of instruments and that they're high resolution, and the Agilent will call it contamination. I don't like to call it contamination, especially not drug contamination, but background noise is kind of what you're seeing. I mean, that can be a killer for these instruments, especially if you're using them as a screen and collecting that the TOF data, the MS1 data. Oh, that can be a killer. And we had experience with that, where we just changed out all of our bottles, cleaned everything, because it was impacting our data. So that, I think, not that we're not clean and we're not careful even with our LC triples, but these are just feel like it's a step further for these types of instruments.
There's a really good one in the chat here. If all resources aside, if you could dedicate one person to having, you know, specialized knowledge of the instrument maintenance and how the software operates, would it be better to do so? Would it be more efficient to pursue that route rather than everyone sort of knowing a bit about the instrument? Although even as I read that question, I already know, probably in my opinion, it would be best to have one person. Although you would want to ensure that that knowledge is going to be passed on should that person, you know, be planning a departure, but and that knowledge doesn't take a short amount of time to come to pass. But I think that's the more efficient route of having people more specialized and kind of being the warehouse of knowledge on that on a particular instrument.
And a person that's willing to teach the rest of the people. So, you know, make somebody that does all of it and really knows everything about it, but then really spread that knowledge as you go to everybody else, and make documents of random troubleshooting things so people get more comfortable with doing the extra stuff and not just one person doing it all the time. And if that one person ever left, you'd be in some pretty major trouble real fast.
That would be the dilemma. Well, I don't see any more questions in the chat at the moment, although someone is typing, so I'll give a few seconds for that question to come in. But any other thoughts or parting tidbits of knowledge you'd like to give anyone who's kind of on the fence about jumping in the QTOF pool?
I will also say that we're using this for forensics capabilities, but as a laboratory, as I know, I think Michael and Josh, you can speak on this too. When it comes to like research as well, people are using this for research. They're using QTOFs and for slightly different applications. But there were times when I just needed to Google something. And while someone might have been using it for research or some other type of application that wasn't specific to forensics, I was still able to find some answers. So I think first and foremost, use your colleagues and your forensics colleagues. That's probably easiest. You probably have the most connections. But I hate to say it, but Google is your friend. And you can find a lot of resources, and it doesn't matter that it says, oh, I'm using this for clinical. That might be a stretch, but oh, I'm using this for clinical. If they still answer your question, that can still be useful information. So I would really say to anyone, if you're sitting here going, my laboratory can't afford to fly someone to a training or fly someone in, but we still need some help, and you know, Google it, see what you can find. I have actually found quite a bit of information. And then there's things like these webinars or workshops at conferences. There are cheaper alternatives where you can still get quite a bit of information. And just as Michael asked a question before, and I said, actually, I know someone who's using an Orbitrap. If you reach out to people, even if you go, I know that you're using a different system, but do you know anyone who's using this other one? A lot of word of mouth too can be really helpful. It doesn't have to cost the laboratory thousands of dollars. It still might, but it doesn't have to. So just wanted to throw that in there.
Yeah, and if you're okay with wading through all the emails that you're going to get from vendors, reach out to them and sign up for all their webinars, because man, they'll put them out, and CSFRE with all the webinars that they have, go through and watch them. It's really worth your time to just see what other people are doing with it, and look at the software before you even get it in house. And there's just a lot to learn here, and lots of ways to do it.
Well, Ryan, to that, you had a lot of information that you shared in your presentation that is probably pretty foreign to the usual, you know, forensic scientists. So where are your sources for that type of information come from?
I'll parrot Kristen. You just got to Google it.
Yeah.
The AutoHotkey thing was actually something surprising enough that our IT department had made available to us. That was like a pre-installed thing on our instruments, or on all of our PCs, that I didn't even know about. But when we started getting a little bit into this, I found out about it and then ran with it. So universities especially, there are packages of software that they have that are allowed on any of their university instruments, and then they have licenses for them. And you can really use that to its full advantage. ChemDraw is another one that you can, you know, bring in those mole files and then play with breaking them apart and find different fragments that you might be able to see in your QTOF. But use all those different tools as much as you can, and reach out to other people to find out what they're using that can maybe help out with that kind of stuff.
One other thing that I thought of, for Agilent, at least their help in their software has gotten better. So there have been times that I have been like, where do I even find this? And I will go to help and I will just search a keyword, and it actually has been very helpful. So I don't think Agilent is the only one. I think a lot of these vendors are also getting much better with their help directories and being able to search the help and providing information as someone, I'm sorry, guys, I don't remember who said it earlier, but the manuals are getting better. So the maintenance manuals are getting better, the operating manuals, and even that help icon. There have been times that Google wasn't working for me. I didn't feel like placing a service call, but I was like, let me just look in the help. This should be easy. And I was able to find it. So sometimes you need internet for those, but hopefully most people have their instruments hooked up to internet.
I have one last question in the chat, and then I think we'll wrap it up. But I'm going to kind of turn it into a hybrid question, just because a few of us may not testify in court that often. But how do you use HRMS in court or in a toxicology report? Is it just the basics, or do you need to have sort of the instrumental specialist to get in there and really explain everything? Michael, do you use any of these off targets in any kind of toxicology report, or just use that to kind of promote the secondary testing via confirmation?
Yeah, we won't report anything from our out of scope unless we can confirm it by either sending it out or if we have a confirmatory method. As far as testifying, I haven't had the pleasure of testifying yet, so I can't speak on that.
I will say that because we have our screen, we don't generally report from our screen method. Everything does need to be confirmed. But our confirmatory methods, we do report from. I'm not sure what they would mean about like putting additional information on the report. Maybe that's just how we report, but we just kind of put the instrument that we're reporting from and then the results. As far as court, I would think that not over explaining would be better. So you want to keep it some basic information. I think if people in the field, right? This is for people in the forensic field. If we're struggling a little bit with concept, imagine what a jury or a judge would think. So I think keeping it as simple as possible while explaining yourself would be best. I don't think anyone in my laboratories had any issues with testimony from any of our confirmatory methods in regard to QTOF.
Yeah, we go to court quite a bit here, but I don't think we've ever really been questioned on the screening or confirmation procedures. But our analysts know way more than anybody else that's going to be in that courtroom. Even an expert witness, I feel like most of them aren't running these. They don't have QTOF experience or anything like that. We've never really been questioned on it, and we've been running it for a few years. And I think that as soon as you get deep enough into what the science behind high mass detection is, that jury is going to glaze over. It's really deep stuff, and it's really hard to explain. Even to like-minded people that are in the science field, I can't imagine explaining it to farmers and day laborers and whatever you're going to end up having on a jury panel, or even doctors for that matter. I try to explain it to some people that are in clinical is even hard, right?
Absolutely. Well, thank you. Those of us behind the scenes today want to thank our presenters for their insight and for being here today. So thank you guys so much for participating. That concludes today's workshop, and we hope that you enjoyed it. As a reminder, feel free to contact any of the presenters if you didn't get to ask your question live today, or if you would like any additional information. Thank you very much, and enjoy the rest of your afternoon.
Thank you for attending today's workshop. As you depart, we kindly ask that you take a minute or two to complete our post-event questionnaire. Your feedback helps us improve our outreach efforts and continue to provide the best experience possible. Thank you again for attending, and we hope everyone has a great day.